Okay, so we're going to do some factorising of quadratic expressions, but we'll come to that in a minute. First of all, I've got a little task for you, which is this. I'm going to give you some pairs of numbers, and I want you to think of another pair of numbers, which when you multiply them, you get 12, but when you add them, they get 7. Okay, that's what sum means. So, when you multiply the two numbers together, you get 12, but when you add the same two numbers, you get the other number, in this case 7. So in this case it could be, say, 3 and 4, because when you multiply 3 and 4 you get 12, but when you add 3 and 4 you get 7. Okay, get the idea? So multiply to 12, sum to 7. And I want you to do it for these pairs of numbers, please. So press pause on the video. I want you to try and find out what pair of numbers multiplies to make the first one but adds to make the second, and then unpause when you're done. Okay, we have unpaused. So multiply together to make 12, but sum together to make 8. Okay, that could be... Oh, I see. I get it. 2 and 6. So when you do 2 times 6, you get 12. But when you do 2 plus 6, you get 8. Okay, so that's that one. Multiply together to make 15, but sum together to make 8. This one I definitely know. How about 3 and 5? Because 3 times 5 is 15, but 3 plus 5 obviously equals 8, so that's that one. Multiply together to make 18, but sum together to make 9. Okay, well I think this is going to be 3 and 6, because 3 times 6 is 18. But 3, it's supposed to be, let's scribble that out, let's do it again neatly. 3 plus 6 equals 9. And then lastly, we've got multiply together to make 42, but sum together to make 13. Well, that's going to be 7 and 6, because 7 times 6 is 42, whereas 7 plus 6, I don't know why I wrote 3 there, 7 plus 6 is obviously 13. Alright, so you get the idea. Now this is a crucial skill for when you're factorising quadratic expressions. Okay, well firstly, let's think about quadratic expression. Well, it's an expression because it's some algebra. It's a collection of terms with algebra, but there's no equal sign. There's no sort of equal sign on the end of it like that. Okay, that means it's just an expression, not an equation at the moment. Now it's quadratic because it's got an unknown in here. It's got a letter, but that letter is in one place squared. That makes it quadratic. That's what it means, okay, when something is squared like that in an expression. Now, we're going to factorise it. Now, factorise, hopefully you remember this, means put into brackets. So we take any factors we can and we sort of put it into the brackets, okay? Now, this is tricky with quadratic expressions. We have a kind of method that helps us do it. Yeah, makes it a bit easier. And we just need to kind of memorise this method, really. It's a hard one to try and kind of understand. I can show you that it works, but otherwise it's just a case of memorising the method. Okay, and we've got a few things here. Now, firstly, what we're going to do, this is a kind of list of what we're going to do. Find factor pairs of the lone number. Right, now by the lone number, I certainly don't mean the x squared or the 7x, because the 7 and the x are together. I mean this one, the 12. We're going to find factor pairs of this, so numbers that multiply together to make 12. And it's always good to do them in order. Now, 1 times 12 makes 12, so that's a factor pair. 2 times 6 makes 12, that's a factor pair. And 3 times 4 makes 12, that's a factor pair as well. Okay, now that happens to be all the factor pairs of 12, or positive 12. Right, then it says, see which pair sums to the lone number with x. Now, by the number with x, we mean this one. It's what we call a coefficient of x. The number that is in front of it tells me how many x's there are. And in this case, there are 7. So I'm looking for which pair of these numbers, either 1, 12, 2 and 6, or 3 and 4, adds together to make the 7. Now, in this case, it is the 3 and the 4, because they add together to make the 7. Right? And then it says, write that pair in double brackets. Like this. So we do a set of double brackets, and we're going to put x in each, And then these two numbers, now this is positive 3 and this is positive 4, because when you times them together you get positive 12, right? So we put positive 3 and positive 4. And that's it. That is factorising a quadratic expression, and that is how we do it. We find those factor pairs of the number that's on its own, that lone number, and then you find which pair of those numbers adds together to make the coefficient of x, that number touching x, and then write it in the double brackets. You're thinking, why? Well, but it's just, it's a useful skill, and it does help us solve them later on as well. We'll come to that later on. But I can show you that it does definitely work. And I'll show you kind of why it works as well. All right, let's change pen colour so you can see more working out here. Let's imagine we've got the double brackets. Let's do it the other way round, right? Because what we're saying is this expression, this x squared plus 7x plus 12, is equal to this. It has to be equal. We've basically factorised it. We've taken out factors, put them in brackets. Let's do the opposite. Let's expand the brackets and see if we end up back here. And I'll show you where these numbers come from. And we're going to do it with FOIL. Okay, remember firsts, outers, inners, and lasts. So first things in the brackets. X times x equals x squared. Now that's why we have in the brackets the two separate x's, because it makes the x squared. It makes this. Yeah. Then outers is the next one. O, outers, the outside things, times those together. So we get 4x. Now that doesn't seem to appear in my expression anywhere, so we'll carry on and sort of see what happens next. Okay, I, inners, so that's the inside things. We'll multiply those together because we're expanding our brackets, we're multiplying them out. Now 3 times x is 3x. Again, that doesn't appear in my expression anywhere, but you know, never mind, maybe we'll see it in a minute. And L for lasts on FOIL. That's the last thing in each bracket. In this case, the 3 times by the 4. Now 3 times 4 is 12, which is in my expression. And actually, look at this. 4x plus 3x. Well, 4x plus 3x, that simplifies, doesn't it? We can put those together to make 7x. That does appear in my expression. Right, so if I just tidy this up a little bit now, we've got x squared plus 7x plus 12. I am back where I started. Now, where did these numbers come from? Right, now the 12 came from when I expanded these brackets and I multiplied the two numbers together. So that's why I'm looking for a pair of numbers that multiplies together to make that number, that lone number, 12. And the number touching x, well, that came from adding the two numbers together, because I got 4x and 3x, and then I added them together to make the 7x when I simplified. That's why we need the same pair of numbers to add together to make the coefficient of x. So that's why it works. We need a pair of numbers that multiply together to make this number, but add together to make this coefficient here. Okay, that's why we're doing that skill of finding pairs of numbers that both add and sum to, you know, the numbers we want. Right, so let's practice two more. This is how we do it, okay? So we're looking for factor pairs that make this last number, and write them all down. Well, 1 times 8 makes 8. 2 times 4 makes 8. Awesome. Well, there aren't any more, so that's that first bit done. Now, see which pair of numbers, which pair sums to the number with x. Which pair of numbers sums to make this coefficient? Well, 1 and 8 makes 9, 2 and 4 makes 6. So that is the pair of numbers that add together to make that. So if I want to write this in a set of brackets, if I want to factorise it, I put an x in each one because that's the letter we're using, and we have the two numbers that we've got here. Now they're both positive, so these are both positive. X plus 2 and x plus 4. Oops. Oh, that's really messy now. That's going to really bug me. But okay, so you get the idea. So whatever those two numbers are, they go in the brackets. So x plus 2 and x plus 4. Let's try it again. Okay, so pairs of numbers that make this number. So factor pairs. Well, 1 times 27 makes it. 2 doesn't work. 3 times 9 makes that number. And any others? 4, 5, no other factor pairs for 27. Now I'm looking for the pair of numbers. Which pair adds to make 12? Well, 1 and 27 make 28, but 3 plus 9 makes the 12. So those are the numbers I put in my double brackets. I put an x in each, and these two numbers. Now they're both positive, so we put that. Positive 3, positive 9. And they've both been factorised. Both my expressions have been factorised. Okay, so pair of numbers that multiplies together to make this number, and then look at which pair adds together to make this one, and then put it in brackets. Easy, huh? Yeah? And that was all 3 of my stages done. So try it. Now you might need to go back and watch the video again, or you might be happy to carry on. I want you to pause the video. I want you to try these 3 expressions here. Let's factorise them into double brackets and see what we get. Okay, so pause the video now. We have unpaused. Let's have a look. Okay, so pairs of numbers that multiply together to make 3. Well, 1 times 3, and well, that's it, isn't it? Right, well, conveniently, that number is also the pair of numbers that adds together to make 4. So that's what I need in my brackets. So we're using x, so we'll put x in each, and then 1 and 3, and they're both positive, so these are both positive. Okay, x plus 1 and x plus 3. Okay, factor pairs for 14. Or 1 times 14 makes 14. 2 times 7 makes 14. And no others do. Now, which pair adds together to make positive 9? Well, 1 and 14 make 15. It must be 2 and 7 that make 9. So we'll put them into brackets. We'll put an x in each bracket at the start. And then 2 and 7, they're both positive. So 2 and the 7. Okay, x plus 2 and x plus 7. Keep in mind, if I expanded this, I would get back to what we started with, definitely. That's how it works. And factor pairs for 18. Well, 1 times 18 is 18. 2 times 9 is 18. And 3 times 6 is 18. Now, which pair adds together to make 9? 1 and 18 makes 19. 2 and 9 makes 11. And 3 and 6 is the one I want. That is the one that adds together to make 9. So I put them in a bracket. Let's put x's in there, and then these are both positive, the 3 and the 6. So they're both positive in the bracket as well. X plus 3 and x plus 6. Okay, sorry about the writing. I'm doing this outdoors on a tablet. It's pretty hard, and my writing's bad. But anyway, let's move on. Let's try something a bit harder. So harder examples. Now, it's always the same thing. You do the same thing every time, you know. So it's always those factor pairs. So 1 times 8 makes 8. 2 times 4 makes 8. And then find the pair that adds together to make this. Now the problem is here, this isn't really 8, is it? This is negative. Now, if I'm going to multiply 2 numbers together to make this, well, one of them is going to have to be negative, or it's not going to work. So, for example, I could have negative 1 times 8 to make that, or negative 2 times 4 to make that. But that does work, doesn't it? Negative 1 times 8. But look at this. How about 1 times negative 8? Surely that works as well, doesn't it? And 2 times by negative 4 also works. So it's the same set of numbers, but the first time I do them with the first number negative, the second time I do it with the second number negative. Now, one of these 4 pairs will add together to make this one, the positive 2. Okay, so minus 1 and 8. Put those together, I get positive 7. Negative 2 and positive 4. Look at that. That's the one. I'll show you. Because if I start at negative 2, then I add 4, I get positive 2. So that is definitely the right one. And so, once again, I put in some double brackets, start each one, in this case with an x, and then put these numbers in. Now the 2 is negative, so it also needs to be negative in the bracket. And the 4 is positive. That's positive. Now if I expanded this, I would get x squared plus 2x, but minus 8. Can you see that, where that minus 8 comes from? The minus 2 times the 4. Yeah, positive times a negative makes a negative. Right, same thing here. Negative 18. Right, so let's think of factor pairs for 18 first. That's the easy way. So 1 times 18, 2 times 9, 3 times 6. Now this number is negative, isn't it? which means it could be that the first number in each of my pairs is negative. Or it could be, if I use the same factor pairs, it could be that the second number is negative. Okay, so 3 times negative 6, 2 times negative 9, or 1 times negative 18. Right, so which pair, when I add them together, gets me negative 3? Well, I'm going to put you out of your misery, I can see already. This is 3, take away 6. That's the pair that makes negative 3. So that's the one I want. So put them in a bracket. It's always x at the start, if that's the letter in your expression. And I've got 3 and negative 6. So the 3 is positive, but the 6 is negative. Okay, so find those factor pairs. Now, if this number is negative at the end, you need to do your factor pairs twice. Once with the first number negative, once with the second numbers negative, and then find which pair adds together to make this number here, that coefficient of x. Okay? Yeah, not sure. I can feel you're not sure, but still, there are 3 questions for you to do. I've noticed at the bottom one here, look, it's just got x squared plus x minus 20. It's a good idea to think of that as 1x. That will help you out. Okay, don't just think of it as x, but 1x, and that will help you with your calculations. So I want you to pause the video, try and find those factor pairs, especially with the negatives, and find the ones that add together to make the coefficient of x. Okay, off you go. We have unpaused again. Right, factor pairs for negative 10. Well, let's just do pairs for 10 first. 1 times 10, 2 times 5. And that is it. Now, this 10 is negative, so it could be that the first numbers are negative, and they would all make negative 10 when you multiplied them. But it could be that the second number is negative in each pair. Now, one of these pairs is going to add up to positive 3. And which one is it? Well, it's this pair here. Because if I start at negative 2 and then I add 5, I get positive 3. Okay, so the expression that I want is this. I've got negative 2 and positive 5. So we put it x with negative 2, x with positive 5. Okay, and that expression would multiply out to make this one. Done. Yeah? Right, negative 14. Okay, factor pairs for 14 first. 1 times 14, or 2 times 7. Now this is negative 14, which means it could be that the first number is negative in each of our pairs, or it could be that the second number is negative in each of our pairs. Right? But which pair adds together to make negative 5? Well, that's going to be positive 2 with negative 7, because 2 take away 7 equals negative 5. So that's the pair I want. Put them with an x. Now the 2 is positive, so it's positive 2. The 7 is negative, isn't it? So it's negative 7. There we go. That's my expression. It's factorised. And lastly, negative 20. Well, 1 times 20 makes 20. 2 times 10 makes 20. And 4 times 5 makes 20. Now it could be that the first number, because this is negative, this negative 20, could be that the first number is negative on each pair. Or it could be, if I write the pairs again, let's just do them over here. It could be that the second number in the pair is the negative 1. One of them must be negative. Now one of these pairs is going to add up to make this positive 1, because it's positive x, so it's positive 1x. So 1. Which pair goes together to make positive 1? That one. That pair has a difference of positive 1. If I start with negative 4 and I add 5, I get to positive 1. Alright, so those are the numbers that I put in the brackets. X take away 4 and x plus 5. And that's the only pair that will work. Alright, tick, tick, tick. Okay. Right, a tricky one for you to have a look at. See if you can adapt our knowledge. It's pretty much the same thing, but there's something slightly weird obviously going on with this one. And just start doing those factor pairs and see what happens. Alright? Okay, so pause the video, see if you can figure this one out, and unpause when you're done. Okay, we have unpaused. So factor pairs for 10, and it's positive 10, which is nice and easy. So 1 times 10 makes 10. 2 times 5 makes 10. And no other pairs. Right, which pair adds together to make -7? Well, none of these. That doesn't work. How can that work? Because I can't do 1 plus 10 and get 7, or 2 plus 5 and get 7, because this is negative. 2 plus 5 is positive 7, not negative. The only way this is going to work is if they're both negative. And it's actually this pair that we're after. The -2 and -5. And I'll show you why. Because look, imagine -2, imagine -5. And I'm multiplying them together. Well, what happens when you multiply two negative numbers? You get a positive. Which means, so when I put this into brackets, it should be x minus 2 and x minus 5. That is the worst writing I've ever done. I'm so doing that again. Right, x minus 2 and x minus 5. Yeah? Okay, and that's what we're after. So this is a kind of special case. If this last number's positive, but yet your numbers still can't add up to make this one because it's negative, well then they must both be negative to make this negative number. Otherwise we'd never be able to make it negative, right? Okay. Right, your job now is to go off to this URL. There's a link in the Show My Homework. I'd rather you clicked on the link in the Show My Homework. This is only here in case you've lost it, and for my reference. Go there, and I want you to do these, and then I would like you to submit your score in a message or a PDF or whatever it is on Show My Homework, so I know what score you've got, please. Don't just ignore it. I really need to know what you've got. Okay? Right, you might need to watch the video again, possibly, but otherwise, good luck. I hope it goes well.